This lesson is for section 8.3 on zero and negative exponents. Today's target is to continue to simplify expression using properties of exponents. So we've got two last properties to learn. The first one we're going to start with is when it's a zero exponent. Okay. Anytime we have a number raised to the zero power, so here we have some number raised to the zero power, it's always going to equal 1. So to finish this sentence off here, any number raised to the zero power will always equal 1. So let's get started with our first example. It's pretty straightforward. We have a base of 5 raised to the zero power. So 5 to the 0, doesn't matter what that number is, it's always going to equal 1. Now number 2 is a little bit trickier because remember what I told you, that any number raised to the zero power is going to equal 1. Well, some people will think that this whole thing is equal to 1 because they see this 0 here. Well, really the only thing that's being raised to the zero power is just the x, right? So I have 2 out in front and then times x to the 0, which is 1. So overall I have 2 times 1. My final answer here is actually 2. Now number 3 complicates it even a little bit more because now I have two bases on the inside here, both being raised to the zero power. So negative 4 to the 0 is 1, and x to the 0 is 1. In other words, since this whole thing is being raised to the zero power, I'm going to get just 1. So the difference between examples 2 and 3 is that here only x is being raised to the zero power. Here the entire thing is being raised to the zero power, so that's why it's going to equal 1. Now our last example looks really tough because we've got this entire inside here and it looks like we got to simplify a whole lot of stuff. But if we notice, and you should be careful when you see a quiz question like this, if it looks really complicated, always look to see what that power is raised to on the outside. Right now we've got it raised to the zero power. Remember, anything, including this big expression here, raised to the zero power is actually going to equal 1. So there's no work involved here because the whole thing has to equal 1. It's kind of a fun problem. All right, the last rule here is when we have negative exponents. So I'm going to tell kind of a little story here. When you see a negative exponent, he's sad. Okay, this is a sad guy. And he's kind of mad at his parents. I know this is a lame story, but just bear with it. When he's negative, he wants to go to the opposite side of where he's at. So think of this as a to the negative third all over 1. So we're going to make this a fraction. Now he's upset upstairs. He's gotten in a fight with his parents, I don't know. Now he wants to move downstairs to make him happy. When he moves downstairs, he becomes positive again. So a to the negative third becomes a to the positive 3 on bottom. But when we have a fraction, we can't just leave it, with nothing on top. So I'm going to put a 1 on top. So he moved to the bottom, right? Think of this as like 2 stories. Top story, bottom story. He wants to go to the basement to get happy again. Okay, I know that's a lame story, but hopefully that'll kind of make sense. When you start off negative, you got to switch floors and go to the opposite floor. Okay, so when you raise a base to a negative power, the exponent wants to move to the opposite side of the fraction bar. Okay, so he started on top, now he wants to go to the basement. All right, now for number 5, this time, this exponent, he's unhappy downstairs. He wants to go upstairs. So if he goes upstairs, now he becomes happy again, so it becomes x to the positive 7th on top. And since he's up top, you don't really need to put over 1 because it's kind of assumed that it's always going to be over 1. So it's up to you. If you want to make it over 1, you can, or you can just leave it as x to the 7th power. This would be my final answer. Now, y to the negative 9th. Right now, he's upstairs, right? He's upset upstairs. He wants to move downstairs. And once he does that, on top, there would be nothing left, so I'm going to leave a 1 there, and then I'm going to rewrite this y to the negative 9th as y to the positive 9th. I'm going to make that positive exponent because now he's happy in the basement. Now, for example 7, okay, you got to be careful that you don't move stuff all the time. It's only going to move if you have a negative exponent. Okay, so here, the only negative exponent I see belongs to the 3. So the 3 is going to move. Okay, so right now, there's nothing up top, so I'm going to leave a 1 there. And then I'm going to put 3 to the 2nd power, positive now, 3 to the positive 2nd power on the bottom in the basement. And the x is going to stay where it is because he's not unhappy. He's fine where he's at. So we just keep that x there. Now we go ahead and simplify this in our calculator. 3 squared is 9. So this would become 1 over 9x. And there's my final answer for that, number 7. Now number 8 is another tricky one because once we learn this whole idea about the negative exponents, people want to move numbers like this, -3. But you got to be careful because -3 is not unhappy. It's only if he has a negative exponent, like the x here has a negative exponent, that he's going to have to move. So that -3 is actually going to stay put. It's not unhappy. It's fine upstairs. So we're going to leave that -3 there. But we do have to move this x to the -6 to the basement. And this x to the -8 that's already in the basement is going to have to come upstairs. So I'm going to rewrite this. I have x to the +8 on top now, and x to the 6th on the bottom now because they're going to both switch spots. Now when I look at this overall answer here, I need to simplify just a little bit further. Since I have variables with the same base here, so here's my power, x to the 8th over x to the 6th, I have to use that rule we used yesterday, or that we learned yesterday that we were using in class today. I need to subtract those exponents. So that becomes negative, whoa, that's a little too thick. That becomes -3x to the 2nd power when I subtract 8 minus 6 to get x to the 2nd power. So there's my final answer for number 8. All right, last but not least, number 9, I think is another tricky one. Again, we're going to practice all different types of problems, and we're going to see problems very similar to this tomorrow. So if you're not sure about how to do one of these, don't worry. We're going to practice it more in class tomorrow. But anyways, for number 9, we have a base of -2. Okay, -2 isn't necessarily unhappy. It's this -3 here. It's going to cause this all to move to the basement. So right now, this whole thing, if I want to think of this as over 1, that helps me to realize I need to move this whole thing to the basement. Okay, so up top, nothing would be left over, so I'm going to leave a 1 there. And on the bottom, I now have -2 to the +3rd power. So now he's happy in the basement. And now I have to evaluate this. So this is just going back to, the rules that we've been practicing before. When you have a negative raised to an odd power, overall, your answer should be negative. So I'm going to get negative and then 2 to the 3rd power. My calculator gives me 8. So that final answer here is -1/8. All right, so that's the end of the lesson. Tomorrow we'll practice this a little bit more. Nice job. See you in class.